We have another example on the board. Please notice that this time we have two power supplies and we have two different diodes connected in parallel, right? And they're connected with different polarities, okay? They're going to work in a little bit different way like it was before. So what we're supposed to do first, we're supposed to just realize that anytime I have 12 volts, it means, okay, you're supposed to automatically see, right, in your mind that we have DC power supply connected to this terminal by positive terminal, and I have negative, and I have another power supply connected to the resistor by negative terminal. Why? Because I have negative sign. Over here I have positive sign, that's why I have positive, and because I have negative, I have power supply connected by negative terminal. Okay, next I'm supposed to connect them together, and this is going to be my ground. Okay, so at this moment I can simply say this is my voltage source 1, which has value of what, 12 volts, and this is my voltage source 2, okay, which has value of 6 volts. Okay, so next what we're supposed to do, we're supposed to simply look at the values of voltages. We have 12 volts and I have 6 volts over here, okay? You have to always look at the strongest voltage source, okay? And you're supposed to also look at the polarities of the voltage sources. Okay, so let's take a look at the strongest voltage source. Strongest voltage source is going to dictate in which direction current is going to flow in the circuit. So this voltage source is going to push the current from positive terminal to negative, okay? Remember, always look at the strongest one. So theoretically, my current is supposed to flow in this direction, clockwise. So this is my I total. Next, I'm supposed to look at the diodes. Please notice that the silicon diode has the arrowhead, right, pointing in the same direction like my I total. And germanium diode is going against my current. So it means that my silicon diode is going to be on the on state and germanium is going to be reversed biased. It means it's going to be in the off state. So it means that this diode is not conducting. Okay? So what we're supposed to do next? We're supposed to simply realize that we're not going to consider this diode, okay? So this diode is going to behave like an open circuit, okay? So the whole current is going to go by the silicon diode. So current goes in this way, so I have positive sign, negative, and I have positive and negative sign. Let's write the KVL equation for output voltage. I have a V out. Because if I'm going to go counterclockwise, right, I'm not going to see any resistors on my way to ground. That's why I'm going to find V out simply by looking at the voltages, right, and simply write that I have negative V silicon. Why negative? Because I have negative sign, I'm going from V out, okay, so I'm going this way, I see negative voltage across the silicon diode plus the voltage source. Okay, so I have negative 0.7 volts plus 12 volts. This is equal 11.3 volts. So I can say that V out is equal 11.3 volts. Next, we're supposed to find the current in the circuit. In order to do so, we're supposed to find what current goes through the resistor first. In order to find the current which goes through the resistor, we're supposed to find the voltage across this resistor, because current is equal voltage over resistance. So in order to do so, we can write that V out is also equal voltage across the resistor minus voltage source 2, because I have positive. Okay, so I'm going to write VR, and I have minus voltage source 2 because I'm going this way this time. So I have minus voltage source 2. So I can say that in order to find VR, I'm supposed to use simply algebra. I have to solve this equation for VR. I'm going to move negative voltage source 2 to the other side, and I'm going to have V out plus VS2 is equal VR. Okay, so I have VR is equal V out, which we found is equal 11.3 volts plus voltage source 2, which is equal 6 volts. This is equal 17.3 volts. So this is the voltage across the resistor. In order to find the current, IR, this is going to be also equal to I silicon, because the current is going to go right like this from voltage source 1 by the silicon diode, by the resistance, and by the second power supply. Okay, remember, germanium diode is going to behave like an open circuit. So I can say that IR is equal ISI, and this is equal VR over R, where VR is equal 17.3 volts over the resistance, which is equal 2.2 kilohms, and this is equal 7.86 milliamps. Okay, so this is the current which goes through the resistor and current which goes through the silicon diode. We have to find the current which goes through the germanium. We said that germanium diode behaves like an open circuit, so I can simply erase it. So anytime we have open circuit, there is no current going through. So we're supposed to say that IGE is equal 0 amps. Now we can say that the problem is solved.